In this lecture, we will talk about solving logarithm equations and exponential equations. So let's look at logarithm functions or equations first. This one is log x squared plus 1 minus log x plus 3 equals 2 plus log x minus 3. We know without writing the base here, we know that means base is 10 by default. So you may put 10 here. Okay. And then here is subtraction. Based on the property of logarithm, the left-hand side, we can change the subtraction into division. Okay. And here base is still 10. So x squared plus 1 divided by x plus 3. Now right-hand side is 2 here. How we are going to combine those two together? You know, if 2 is the result of a logarithm, then 2 would be equal to log base 10 to the something. And then we know if the base is 10, then 2 equals log base 10 to the something. This 2 must be the exponent of this 10. Okay? And then you know if 10 to the 2 is 100 squared, and you see that log base 10 to the 10 to the 100 is 2. So basically here we can replace this 2 by log base 10 to the 100. Okay? And then plus log base 10 x to the x minus 3. So this is the key step, the technique. Okay? 2 is log base 10 to the 100. Alright. Then you can combine those two, because here is base 10, here is base 10, and here is addition. Then you can change this to multiplication, 100 times the quantity x minus 3, right here. Okay. Left hand side, we didn't do anything, so we copy it down. Again, by default, we don't need to write 10 here. Since it's 10, we can just write log. Now is the time to drop log. You cannot drop log right here. Okay. Yeah, here there is a 2, you cannot drop it. You also cannot drop it right here. That's a popular mistake. Okay, because here is addition. As long as you get finally the left hand side is log, a quantity, the right hand side is also a log and another quantity, then you can drop it. If there are additions involved, you cannot. Or subtraction involved, you cannot. After we drop it, so x squared plus 1 over x plus 3 then equals 100 times x minus 3. Now, x plus 3 is a denominator. We don't like denominator, so both sides multiplied by x plus 3. And this x plus 3 cancel this x plus 3. Left hand side has x squared plus 1 left. Right hand side, x minus 3 plus times x plus 3. There is a 100 in front of it. You can FOIL x minus 3 times x plus 3. X times x is x squared. 3 times x is 3x. Negative 3 times x is negative 3x. And negative 3 times positive 3 is negative 3 squared. You can see you can cancel those two terms in the middle. That's basically x squared minus 3 squared is 9. So x squared minus 9. Remember, we have 100 in front of it. So 100 times x squared is 100x squared. And 100 has to time negative 9. So you get negative 100. That's by distributive property. Okay. Now, both sides minus x squared, then you can cancel this positive negative x squared. So left hand side has 1. Right hand side 100x minus 1, 100x squared minus 1x squared. So that's 100 minus 1, that's 99x squared. Okay. And we have a negative 900 here. We copy it down. Then plus 900 on both sides. You cancel this too. So you have 900 plus 1 equals 99 times x squared. Both sides divided by 99. So you then cancel this 99 with this 99. You know 99 divided by 99 is just 1. Okay. So right hand side we have x squared. And the left hand side is 901 divided by 99. Choose the square root. You have positive negative. Numerator, choose the square root is 901. Denominator is choose the square root. 99 is 9 times 11. And 9 we know is 3 squared. So radical 9 is 3, and radical 11, you then keep it. Okay. This is the answer. If you want to rationalize this one, is fine. But up to this level, we can simply keep it. Okay. Okay. So here basically we did for this equation is that we want to use the property of logarithm. Here is subtraction to division. The technique here is change 2 to log base 10 to the 100. And use the property from addition to multiplication. Then you drop it, log. Then eliminate denominator, so you get looks like a quadratic function until you choose the square root. Here we didn't choose the negative. It's because if it were negative, you put it right here. Negative number minus 3 still is a negative. Log a negative number doesn't make sense because the domain of y equals log x, this x has to be greater than 0. That's why anything behind log has to be positive. Okay? If it's negative, it doesn't make sense. So we choose positive right here. Now, this is for the question 1. Question 2. That's log x to the 5th. And here it equals log x and then whole thing squared. Remember those two are different. This one x to the 5th. This one is log x and then the whole quantity squared. By the property of logarithm, bring 5 down to the front. That comes to be a multiplication. 5 times that. That's a multiplication. And then log x squared, you can keep it. You cannot take this two down to the front. That doesn't make sense. Okay, it has to be 5 here. Then you can bring it down. Here, this square x are all the log, so you cannot bring it down. Okay. All right. Now, here is log x. Here is log x. We may assume this log x is a u. It is a new variable u. Why we need to do that? Because if here is a new variable u, that's 5 times u. And here log x whole thing squared is just a u squared. And this one looks very easy to solve. That's a quadratic one. Okay. So you see both sides minus 5u minus 5u. You cancel positive negative 5u. Then left hand side is just 0. Left hand side, right hand side up here is u squared minus 5u. So you put it on the left. U squared minus 5u. You put it on the left. Left hand side is 0. You put on the right. Pull u out. Okay. U squared. So you pull one u out, you have another u. You pull another this u out, you have a 5. So that's u times u minus 5 times. A product of two quantities is 0. Either the first one u is 0 or u minus 5 is 0. If you plus 5 on both sides, you may cancel positive negative 5 here. So then u equals 0 plus 5 is just 5. Remember what was our u? U was log x. So if you have a u is 0, is actually log x is 0. If you have a u is 5, is actually log x is 5. Okay. Now, log base 10 to the x is 0. Then what could x be? You see, again, 0 equals a log thing. This 0 always is the exponent of this 10, base 10. So you know 10 to the 0 is 1, so x is 1. Similarly, the same right here to the above. You see here log without writing base, that means base is 10. Okay. If it equals 5, then log something always is an exponent. Exponent of this base 10. So base 10 to the 5th equals x. So 10 to the 5th is basically, if here is 5, then you have 5 zeros. Okay, if exponent is 5, you have 5 zeros. So x has either 1 or 100,000. That's the solution. These two examples are about logarithm. Okay. Now let's look at exponential equations. Exponential equation, this example, y equals e to the x minus e to the negative x over 10. From here, you want to notice that e to the negative x is e to the x to the negative 1. Because right here, negative 1 with x is x times negative x. It's not add or subtract. Okay. The reason we do so is because we can review e to the x as a new variable u. So we let e to the x be a new variable u. Okay, so basically here is u. This big thing is u. e to the x is u. E to the x is u. We also don't like denominator 10, so then both sides multiplied by 10, you cancel that. The left-hand side, 10 times y is y. The right-hand side, you cancel those two. Here is e to the x, which is u. And here is e to the x is u to the negative 1, so that's why we have u to the negative 1. Remember, e to the negative 1 is 1 over u to the first. That's 1 over u. So you may write this one as 1 over u. And then here is u, you copy it down. 10y, you also copy it down. If we don't like the u down on denominator here, we'll get rid of it. How? If it's down on denominator, multiply u to everyone in this equation. Then you can cancel this u. That's 1 left. U times u is u squared. 10y times u is 10y dot u. Dot means multiplication. Now, you have a u, you have a u. And here, if both sides subtract 10yu minus 10yu, then you can cancel this one. Left-hand side is just 0. Right-hand side is u squared minus 10yu minus 10yu. This is 10y times u minus 1. Okay, that's right-hand side is all those three quantities. This is a quadratic function. It has a equals 1 for this coefficient u squared. It has b equals negative 10y. It has c equals negative 1. And here is the quadratic formula. Okay, that's u equals negative b plus minus radical b squared minus 4ac divided by 2a. Now, we have a, b, c values here. We plug in. And then you can see b was negative 10y. There was a negative in front of it. So that's negative. And then b is negative 10y. So then you have a negative, negative is going to be positive. Plus minus b squared, that's negative 10y squared, minus 4a is 1, c is negative 1. Okay? So then we end up with this. Again, negative, negative is positive. And then here, negative 10y squared is 100y squared. Negative, negative, so you have a positive 4 here. These two, as a denominator, it divides 2 tens upstairs. Okay, so 10y divided by 2, and the whole quantity divided by 2. We know 10y divided by 2, that's 5y. Okay. And the right here, we have a 2 is actually radical 4. So 4 to divide 100 is 25y. And 4 use 4 to divide this 4, you have 1. So that's 5y plus minus radical 25y squared plus 1. That's all u. You find u was e to the x. That's not enough. You need to find x. Okay, now look. Replace this u by e to the x. That's the one right here, e to the x. And then we keep 5y plus minus radical 25y squared plus 1 here. Okay. Now look. E to the x is always positive. So right here, this quantity is bigger than 5y. So 5y minus a big quantity is going to be negative. So that's why we need to drop this negative sign. Why this big quantity is greater than 5y is because radical 25y squared plus 1 is greater than radical 25y squared. Okay, because here you add 1, here we don't have 1. So of course this one is bigger than that. And that's 5y. 25 squared is 5. 25 square root is 5. And then radical y squared is just y. Okay. So here we actually need to choose positive to drop this negative. Now e to the x is 5y plus radical this quantity. Then what is our x? So right here you got to use the definition. If you have a e to the x equals a quantity by the logarithm definition of the logarithm, okay, that would be log base e. Log base e, yeah, because by the definition of logarithm is log always end up with the exponent. Remember that. Exponent of what? Of this e, base e, to the number, the quantity right here. But we know e, log base e is the natural log. So you write natural log, ln stands for natural log. Okay, so x equals natural log 5y plus radical 25y squared plus 1. Okay. This is the final answer for that. Now, that was the e to the, that's the exponential function. Let's look at this one. Okay. This one, it's a equals p times the quantity 1 plus r over n, this whole quantity to the nt. We want to solve for t. This one was solved for x. Okay. Now, in order to take this exponent n to the t down, we both sides needs to choose log. So we choose natural log. Okay. If we choose natural log on both sides, then this n to the t can be brought down to the front. Okay, that's the reason. Before we do that, notice p times this whole quantity to the nt. So if here was multiplication, you got to change multiplication to addition first. So that will be natural log p here. And then natural log 1 plus r over n to the n times t. Okay. Then you can bring this nt down to the front. Okay. We didn't do anything here with natural log a, we just keep it. Okay. Keep natural log p here. Now bring this one down to the front. That means this is the multiplication now. Okay. Basically, the logarithm is very powerful. Change the exponent operation to multiplication, change multiplication to addition, subtraction, the division to subtraction. We want to solve for t, so we want to isolate t in this case. Minus natural log p on both sides, you may cancel this one. Then you have a natural log a minus natural log p. This is the left hand side, so we put it here on the right. the right hand side, you have those two cancel each other. So then you have only nt times natural log 1 plus r over n on the right. So let's take this one to the left. Okay? Yeah, the whole thing on the right is this one because these two are cancelled. So this is the one was on the right. Now, you want to isolate t, remember? So then you want both sides divided by n, and then natural log 1 plus r over n on both sides. Because here all in relationship, multiplication. This n cancel this n, this natural log cancel this natural log, so you have a t is isolated. So you solved for t. And then the right hand side is natural log a minus natural log p divided by this big quantity. Okay, n times natural log 1 plus r over n. You know, this might be your final answer. Remember, here is subtraction. You can also write as a division. Okay, a divided by p, right behind the natural log. And you keep denominator as the same. Okay, that would be n times natural log 1 plus r over n. So here, those two examples are not easy examples. Please review this one, and also these two are not easy. That's for logarithm. Okay, remember here those two are different things. So review the lecture, then I will see you next time.